In this video, we're going to learn about inner functions in Python. So inner functions are sometimes called nested functions. And an inner function is when we define a function inside another function. So for example, we could define a function here called outer. Then inside the outer function, we could define an inner function called inner with def inner. And here we could output using print inner function. Then we could call inner inside the outer function. So we could call inner like this. Then we could call outer with outer like this. And if we save the program and run it, we'll get here inner function. So what's happened is we've called the outer function, which we've defined like this. The outer function definition includes the definition of this function inner, which we then call here. And so we get inner function as output when the outer function runs. Now this inner function has the scope of the outer function, which means we can't call the inner function using the name inner from outside the outer function body. So we can't have here inner like this to call the inner function. If we save the program now and try it out, we'll get an error. It says here name error, name inner is not defined. Now functions in Python are what are considered first-class objects. This means, among other things, we can return functions from a function. So what I could do here is from the outer function, return inner. So here we're treating this function like a value and we're returning the function inner from the outer function. So what we could do is store that function into a variable outside the function like this. Variable is equal to the return value of calling outer. Then we could call variable like a function out here. We could have variable and then open bracket, close bracket to call the inner function that's been returned by outer and stored into this variable. So now if we save the program and try it out, we'll again get inner function. Now inner functions can have their own parameters. So for example, we could have the parameter here z, and then in the function, we could output the value of z. We could have print z colon, and then z to output the value of z. Here, we could call inner, and we could supply it with the argument 2. Then down here, when we call outer, this will result in a call to the inner function with the argument 2, and we should output that z is 2. So if we save the program and try it out, we do get that z is 2. Now we would say that z is in the local scope of the inner function. So z belongs to the inner function and we can access it inside the inner function. We can create other variables with the local scope of the inner function. We could have, for example, c is equal to 50. Now we can't access variables with the local scope of the inner function inside the outer function. So I can't, for example, here output the value of c after calling the inner function. C really only exists inside the inner function. If we save the program and try this, we'll get here name error, name c is not defined. Now the inner function can also access variables in the enclosing scope, where the enclosing scope is the local scope of the outer function. So for example, if outer has a parameter x, the inner function could actually access x. We could have here print and x colon and x. And if we pass to the outer function the value 10, that means x is going to be 10. We'll delete this line here that was causing an error. And then if we save the program and try it out, we'll see that x is 10. So the inner function can actually access variables in the outer function. We call those variables in the enclosing scope of the inner function. We could also access the local variable y of the outer function. So if we had y is equal to 5, then inside the inner function, we could output y with print y colon and y here. Then if we save the program and try it out, we'll get that y is 5. Now, to access variables in the enclosing scope of our inner function, those variables do need to be created before the inner function is called. So let me show you an example. Here, we could create the variable a with a is equal to 1 before calling the inner function. Then, inside the inner function, we can access a with print and then a colon and a. And if we save the program and try it out, we'll get that a is 1. But if we had here b is equal to 2, here we've defined the variable after calling the inner function. So now, if we try to access b inside the inner function, it's not going to work. If we save the program now and try it out, we'll get an error. It says name error free variable b reference before assignment in enclosing scope. Now we can read the values of variables in the enclosing scope, like y here, in the inner function by just using the variable name here, y. If we actually want to modify the variable y in the enclosing scope, we have to use the non-local keyword. So let me show you what I mean. We'll delete all this here, and we'll delete all these prints except for the print of y. Then what we'll do is try to modify y. We'll have here y is equal to, let's say, 50. Then down here, we'll output y after calling inner. We'll have print and y colon, and then y. So doing this with y being 5, and then calling inner, where y is then set to 50, and outputting y, which should now be 50, we might expect y here to be 50, because we've modified y and made it 50 when we called the inner function. But if we try it out by saving the program and running it, we'll actually get here y is 50 and then y is 5. So what's happened is here we didn't modify this y variable in the enclosing scope. We actually created a new y variable in the local scope of this function inner. So to actually access the variable y in the enclosing scope, we have to have here non-local y. And what this will do is allow us to modify the variable y in the enclosing scope of the inner function, which is the local scope of the outer function. So here, instead of creating a new variable y that's in the local scope of the inner function, we're instead going to have access to the variable y in the enclosing scope here. So now, when we modify y and make it 50, we'll get y is 50 again here when we call the inner function. But now, even after calling the inner function, because we actually modified this y variable in the enclosing scope, when we output y again here, we'll get that y is 50. So now, if we save the program and try it out, we'll get y is 50, and again, even after the inner function has been called, y is now 50. Now, inner functions are useful for implementing the ideas of encapsulation and information hiding in Python programming. When we create an inner function, we're essentially hiding that function away from the rest of the Python program, and only giving the outer function access to this inner function. By not allowing the entire Python program access to that inner function, we can then change that inner function as much as we like, without impacting the rest of the program, which only relies on the outer function. Inner functions also allow us to implement closures and decorator functions in Python, which are concepts I'll cover in future videos. So this is how we can use inner functions in Python. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers.